Okay. Yes. All right. Hi, everyone. My name is Harry, and we are going to present on the efficiency of phosphorus removal from tile drain system using the predictive models that we have learned in this class. Next slide. So in this project, we use the real data that we observed in the field, and actually we had some data of removal using the biochar, and we added some temperature, precipitation, and humidity and other environmental data from the meteorological stations. And we also had two different fields, and we tried to compile all the data into one and use some categorical variables as well. So here is the data set that we have. We have influent concentration, effluent concentration, air temperature, humidity, size, drainage flux, and etc. So we have altogether of 11 independent variables and one dependent variable, that is the efficiency of system, which we want to predict. And we have total of 716 entries before data processing. And so we did some data cleaning and tried to remove some highly autocorrelated data. So we can see from this plot that phosphorus coming into the system and going out of the system are highly correlated. So we didn't want to skew the model output. So we just got rid of DRP out variable, and we also removed all the blank datas and missing datas in the exploratory data analysis. Next slide. All right. So the significance of this research is to optimize the biocide uses in agriculture process. By determining the efficiency, we can we can properly do the engineering design in the field application. So in this project, we used two different modeling approach. One was generalized linear regression model, and the other one was decision tree performance. Next slide. So, generalized linear regression model, it's pretty much similar to simple linear regression, but it allows a little bit of modification on simple linear regression. So that is, it allows the distribution, different distribution of the dependent variables, and in decision tree model, it can capture the non-linear relationship between the features and labels without any transformation. And it also don't require the feature scaling or normalization. So here is the result of generalized linear regression. So it didn't show pretty good result using GLM model, maybe because it's simply a linear regression. And so while using all the dependent variables and one using all independent variables and one dependent variables, we just got R squared of 0.47 using train data set and 0.37 using test data set. So we tried using normalizing and PCA transformation to get rid of autocorrelation, and we still couldn't improve the efficiency of the model too much. And we also tried getting rid of some independent variables manually, and only used two, and the result was pretty similar using the PCA transform variable. Next. So then what we did was data pruning and normalization. So after cutting off some extreme data and outliers, we got a pretty good result using GLM as well. So the training R squared was 0.72 and test R squared was 0.6, and still it shows that the model is still overfitting because test R squared is pretty lower than the train R squared, but we had already used the normalization techniques, so we couldn't do much from this one. So we tried to make the model prediction better using decision tree.
And here's the decision tree model we have. The left one is a train data set, and the right one is a test data set. We all use all dependent for the train and test data set. And you can say the train data set have a R square at 0.75 and test data set have R square at 0.81. And then we did the model evaluation for the generalized linear model, which has for the train data set, it have R square at 0.72, and for the test data set, it has R square at 0.6, and the GIM also have for train data sets, it have 0.0028 mean square error, and for the GIM test data set, it's have the 0.0032 mean square error. And for the R square train data set of the decision tree, it have 0.75, and for the test data set, it's have R square at 0.81. And for the train data of the decision tree model, we have a MSE at 0.000753, and for the test data set, it's have the 0.000766. And why we are doing the evaluation is because the decision tree model is demonstrating superior accuracy compared to the GRM. This is evident from its lower mean squared error and higher R square values. A lower MSE indicates that the decision trees predictions were closer to the actual values, and higher R square values signify a better fit of the model to the data. And decision tree also is a non-parametric and can model complex nonlinear relationships between variables more effectively than GLMs, which might have contributed to its higher accuracy in our study. GLMs, being linear models, might not capture the intricate interaction between variables as effectively as decision trees. And our future direction, in order to enhance the model we have for the GLM, we will investigate the inclusion of interaction terms to better capture complex relationships, and also implement pruning techniques to prevent overfitting. And also for decision trees, we are also using the pruning techniques to prevent overfitting, and also consider ensemble methods like random forest and gradient boosting for improved accuracy and robustness. And for the data exploration, we can expand the dataset with more diverse data points to enhance models' generalized ability. Like we can use more data from more other fields, and also explore additional variables that could influence phosphorus absorption efficiencies. It means we can use other variables that could influence biochar's phosphorus absorb efficiencies. And thank you for watching our report presentation.